Hi guys, this is a test electronics video demonstration on how to modify the Prober 8x15x06 test fixture kit. So what we want to do is take the parts out, the front panel, the bed of nails plate, and the rear panel, and possibly you can also modify side panels, bottom panel, whatever you want. I'm going to show you all of that today. So to take this apart, first what we will do is take off the bottom panel. Now I'm going to take out these two screws here, just in case you can't see it very accurately. And show you how to take off the bottom panel first. Now you might want to take off, well, you'll have to take off the bottom panel to access the insides. But you might want to modify it, and typically the way this is modified is drill an array of holes for ventilation if you want to put a fan or something inside here. So you take it out like this. Basically, if you didn't see that, there's hooks here. So you got to slide it in and then line it up. So you can slide it back or you can slide it forward, but you got to slide it either back and forward or forward before you can lift it. Otherwise, it's stuck. You can't lift it out. And that's just because it's just a nice trick where we only need to put two screws in here and the edges are held down by this hook. So slide it back, lift it up, and then pull it forward and it comes right out. Now you can get to the insides of your fixture. What you can see in here, this is the lid switch, and you got the inside of the front and inside of the back and inside of the front panel. So let's take the front panels out. Oh yeah, and we will provide a CAD drawing for this bottom panel for your reference. So, taking the front panel off is these screws. Now you may wonder, why the heck are there 6 screws to hold on? This is just a little piece of sheet metal here. Why are there 6 screws to hold on this front panel? And the reason for that is because it's modular. There's inserts. This is just one panel, and I'll put a box of drawers here. This is just one panel covering 3 modular insert locations. There's a bunch of devices that can be modular. I'll show you that. So you remove all these screws and this will come out. And now this is very easy to customize your front panel. So it's just a thin piece of metal with some PEM nuts, and you can cut out whatever you want in here for switches, LEDs, etc. Now, the reason for these modular ports is because we have stuff like this available, where you can get this. You plug a USB in here and you can have the computer watch these 2 buttons and display all the status on these LEDs here. And there's actually, you can watch 4 buttons. There's a wire for the press down switch right here. Let me show you that a little better. Right here's the press down switch, and when we open the fixture you can see that presses down against the switch. So that's the way that works. But yeah, this can be mounted right in here like this, and it's all prefabricated. Then we put a blank in here. Or you can get even more fancy and have this, which is an LCD display. It's a 800 by 480 capacitive touch display. I like capacitive touches, they're the best. You put that right in here, and now you have a capacitive touch screen display for your fixture, if you want to get that advanced. Now I've been taking these out the bottom. Be aware that they can also go out the top, and I'll talk about that a bit later. So, I don't know if I should show you the back or not. It's the same. Yeah, I'll show you the back. It's the same kind of deal. Exactly the same, actually. I mean, they're interchangeable. So, and we only provide one CAD file for these because they're exactly the same. So just if you want, if you want a back panel, you just copy your file and have two files. Or no, actually, I wouldn't do that. I'd copy the image and have two images on one file for your front and back panel. But that's how you do it. And just loosen all these up first. It's faster that way. And then I can spin it off with this end. So, yeah, we'll remove the front and back. And a good thing to show you now that I've got the back removed is same kind of panel, same exact panel. There's no difference at all. What we can put in the back panel. This is a power supply with ventilation on the outside, so it'll cool. This is a 12 volt 2 amp. We have them in 2 amp and 4 amp, and 12 volt is great if you want to put like a USB hub in here or a switch or anything like that. You could put it in here with one of these powering it. And what it does is it just takes, this is just a digital readout for the display of the DC voltage, and it has line, neutral, ground, negative 12 volts, well no, 0, and positive 12 volts. There's no negative 12, it's just a 0 and a positive 12. So you just hook it up real conveniently to this pluggable jack block. Some people call them Phoenix connectors. And then, but yeah, okay, so the way this mounts is just, just like this, real easy. And when you get your CAD files, you'll see that there's an area where there's the whole square with the PEM nuts, and then there's a red area, and you shouldn't go outside the red area, because that red area is covered up right by this. So the usable area is right in here, right there. So don't go outside the red area. Now that being said, here's a fan, okay? And we did not, well, yeah, we kind of went outside the red area, so now this has to be just the grill here, but it aligns. But on the back side, we totally went outside the red area. The PEM nuts are down here, and the fan is over here, so you can do that. It's fine. Just realize that the red area means the outside. That's all. Okay, now, this is another type of power supply you can mount in here. A little bit smaller, ducted fan instead of a standard fan. Okay, so now to the bond plate. That's the bed of nails plate. That's the difficult thing. Or not the difficult, that's the nice thing, because we made it real easy to take this thing out. So basically, it looks complicated from the back side, but it's not. It's just these 8 screws right here, and the whole thing will come right out. And it makes it so easy. I loosened all these just now, and I'll just go through and spin out these. So you take out all of these 4 screws, and it really beats other fixtures where they take a bond plate and they mount all the hinges and everything to the bond plate. So if you want to take apart the bond plate and put it in your CNC mill or drill to customize it, you got to take off all the accessories on the bond plate. the accessories are mounted to the frame on this. So the bond plate just comes right out like this. And now you just got a pure bond plate. And all your accessories, all your latching mechanism is still right here. But you don't have to unscrew it from the bond plate and line everything up. You just drop this back in and it's all self-aligned. You'll get this CAD file. They make them in 3D. I don't see what the reason is for that. I mean, it's 1/4 inch thick. But what you do is you take your board, lay it on here. Of course, there's red lines. Oh, let me show you the red lines. What the red lines mean is, of course, here. So this will be all redlined. So not to go outside this area, and you shouldn't even really go back here too much. This area would be used more for mounting internal things. Like you might want to take your bond plate and mount a power supply to the back side. So, or a data acquisition board. So you'd take a rail, a DIN rail, mount it to here, just two holes, thread them, put some screws in, and you've got a power supply now mounted to the inside of the bond plate like that. And you could then, you know, just snap it off the DIN rail. Here, let me show you a little better. Mount it like this, and you can just snap whatever you want in and off of this DIN rail. So, okay, so then you just put your board on here, like that. And there's a variety of different methods. Nowadays, we mostly use CAD files. So, I mean, I'm talking CAD file now. You take this as a CAD file, this board is a CAD file, and put it together. Then draw circles where you want your test pins, and that's where you drill your holes. And oh yeah, also make sure you do four circles for your tooling pin as well on here. So yeah, that's how easy it is basically to do it. You don't need fancy 3D or anything like that, even though we do provide it. You just need 1D for drilling the circles, tooling pins, cutting out your inserts. The one thing I wanted to do, yeah, is show you why we designed it, some of the things how we did it. So let's look at the back plate, because that's where your wiring is going to be usually. So you'll probably have a bunch of test pins here all wired out to a rear panel connector, right? And you want to take out your bed of nails plate that's wired up to your rear panel connector. And you can do that, well, let me put that in here, because which is the opposite of what I'm doing right now. Basically because, okay, so this is wired to here. You take this out along with this, and the whole thing just comes out like that. And it's all still together. So you don't have to disconnect a bunch of wires to remove the bond plate. Now you can, if you neatly fold this out, you can put this on the CNC machine and update it with more holes, more test pin locations, or whatever you need to do. And then just put it right back in. So just put it in, and trying to do this with standing to the side with hands. But you get the point. It can be taken apart and put together while it's wired together. So, you know, a lot of people will say, well, we've got to have a connector here, then a connector on this so that we can pull it apart. You don't need to do that. You can just leave it all connected and take it apart anyway. So that's the beauty of that design. Okay. What else okay, another thing I can show you is, now, we have what nobody else has, I think. I can't say for 100% because I can't know the whole world, but nobody else has balanced rake. What balanced rake is well, first you got to know what rake is. Rake is when this goes down, it moves forward. Okay, so here it's moving really forward. Here it's moving a little bit forward, and it's still moving forward, only it's moving a lot more down, but it's still moving a little bit forward. And then when you get about here, it's moving backwards. So here it's moving forward as it goes down, and then it's going backwards. But that only works if your test pin is set to the right height and the hinge mechanism is right. So the hinge is set to 0.4 inches. That's the center of travel. The center of the hinge is at 0.4 inches. And with all the math involved and everything, it means your test pin receptacles should be set to 0.15 inches, 0.15 inches high. And that will be the optimum place where full extension of the test pin is contacted when it's going forward, and during the middle there's no rake, and then in the back there's back rake. So then you get just as much forward rake here as you get back rake here. That's the balanced rake thing. So set your receptacles at 0.15, and then everything will be perfect. And then you need to set your adjustment rods here for the test pins to press them down 3/4 to 2/3 of the way the travel. Not full travel. You don't want to press your test pins down all the way for 0.25 inches of travel. You want to set it to about 0.2 or 0.18, I think, which is 3/4 of that. But you just judge it. You want to travel 3/4 to 2/3 of the test pin. Now, another thing, set your test pin receptacles to 0.15 inches for most of them. Most of the test pins that will be contacting pads on the board. But if you get stuff like this, where you're probing here, where it's lifted, about 0.015 right here, 0.015 inches, you need to set your receptacles down a little bit here. So you would set these receptacles down to 0.1. It might not be quite 0.05, but you'd set these receptacles down to match this distance that these are lifted, because you want all the probes to travel the same amount. You want them to contact evenly. Because your probes should all have a continuous force being the same. That way you don't get board rock. Board rock can be worse actually than rake. So even though you're going a little bit below the optimum rake point for this kind of connection, it's okay, especially with 100 mil pins, even 50 mil pins. The rake on this fixture is about half the pointing accuracy of the 39 mil pins, and it's the full pointing accuracy of the 20 mil pins. So the 20 mil pins, 20 milli-inches, 39 milli-inches is what I'm saying, and that's one millimeter, right? Yeah, I think I'll correct that if I'm wrong. It might be 10 mil. No, it's 1 millimeter. I'm not that good with metric, but it's 0.39 milli-inches, and so basically, if you're a little bit off from the center of the 0.4 inches with your travel, you're fine. Now, test pins can only be set to flush or up to 0.25. So if you have a fixture where your hinge pin center is higher than 0.5, you'll always have negative rake. And a lot of fixtures are like that, so they get a bad name, these clamshell fixtures, because of that. Some fixtures are even up at 1 inch, and they just have the most terrible rake. You can't even go below 75 mil pins without wearing them out really fast. But this fixture has a balanced rake, so it's long enough here so that it's doesn't wear out your pin so fast, or doesn't even hit the sides of the pins. Okay, so this concludes the demonstration of how to take apart everything and modify things. I advise that you don't mount parts here because this is kind of like the hood of a car. You want to keep it so you can remove it and access your inside easy. Mount stuff, let's see, I didn't put the screws in, but I think it'll be okay. Mount stuff on the back here is a really good place to mount all your electronics, plus it's close to the pins. If you mount it up here, it's kind of far from the pins. If you're not mounting anything, just wire everything right back to the connectors on the rear panel, and that's might be all you need there. Okay, so this concludes the video demonstration. I'll just put the fixture back together so you can get a double take on everything I did. So, here, I'll take it apart again. So you just put it right in here like this, drop it in, and pull the right screws out of the box. I like to put this together in kind of a, put everything together loosely first and then tighten it down at the end. That way you don't have one screw pulling things off. Let's put all the screws in there. And a real neat way is to just use these things and spin it on. And it's all just finger tight and then tighten it down at the end, because this is better than an electric screwdriver. We use electric screwdrivers for torque, but you can easily cross-thread something with an electric screwdriver, so I don't like using them for this kind of precision stuff. So you just do finger tight everything, and it goes together fairly easy. And then you go through, and I like to tighten in kind of a crisscross fashion. That kind of makes sure that everything tightens evenly as well. You don't need to turn it too much here because I already finger tightened it all the way down. Now I'll just go through and make sure everything is good and tight. And, yeah. You can see my coffee blue. Okay, so that's that, and a good way to put these panels in. It's just like this. Now, if you would have had wires on here, you'd put these panels in along with the bed of nails. And it doesn't matter if it's right side up, upside down. I mean, it mounts anyway. So, well, once you cut out and put your parts in there, it's going to matter. But as the blank plates or blank inlays, panel inlays, it doesn't matter. Front, back, right side up, upside down. It's all symmetrical. It fits. Yeah, I'll just make this whole video taking apart the whole fixture and putting it back together just to show it can all be done in a video. It's so quick and easy to take this fixture apart and put it together again. And back panel. So right now, we're well more than halfway done. Only have the back panel and bottom panel. The bottom panel is only 2 screws. These just have a lot of screws because, as you can see, it's modular. You can cut this thing in 3 ways and put all kinds of neat things in here. So everything self-aligns a little better. And yeah, the holes are all punch pressed out, so they're all nice and precise. So you don't have binding screws or anything like that. It all just spins together real easy. Tighten that. Okay. And top panel, and we'll be done. Oh, that's just 2 screws. As you can see, I just slid it kind of in, and one more screw. And yeah, I tighten this down. Don't do that. Put them both in there, and then tighten. Just like that. Okay. Maybe that gives you a few little tips. So now the fixture is done and we're back to where we started. And this fixture has been disassembled and reassembled. Okay, this concludes the demonstration of the parts you can take out, what CAD files we provide for you so you can make your custom test fixture. Thanks for watching.